Welcome to this explainer. Today, we are focusing on Lesson ID, STEM Python Unit 07, Lesson Pack 04, Variables Assessment Rehearsal Video Overview, exactly titled Variables Assessment Rehearsal Video Overview. If you're a Grade 7 Python coder gearing up for your Unit 7 assessments, you are in exactly the right place. We're going to use the official Python documentation to clear up some tricky concepts regarding variables, lists, and function parameters. Basically, we're going to break down what actually happens to your data when you pass it around your code, and we'll practice with some assessment-style questions to make sure you're totally prepared. Let's get right into it.
So, we're going to kick things off by tackling a really common misconception. Think about this for a second. When we create a list, store it in a variable, and then pass that variable into a function as an argument, what actually happens when the function adds an item to it? Does our original list outside the function change? Or does it stay exactly the same? It's a really fantastic question, honestly, because it gets right to the heart of how Python manages memory behind the scenes.
A lot of people, when they're first learning this, just assume that when you pass a list into a function, Python simply hands over a temporary copy, right? And if that were true, any changes made inside the function would just vanish when the function ends, leaving your original list totally safe and untouched. But, spoiler alert, the reality in Python is quite different. That original list, it's permanently changed.
This whole situation brilliantly illustrates a concept from the official Python documentation's footnotes on defining functions. Python uses what's best described as call-by-object reference. Basically, when you pass your list variable into a function, you aren't passing the actual values, and you definitely are not passing a copy. You're passing a reference. Think of it like a direct pointer to the exact same list object sitting in your computer's memory. Both the code outside the function and the code inside the function are staring at the exact same piece of data.
Which brings us to another really critical concept from the Python data structures documentation, and that is mutability. Lists are mutable objects, meaning their contents can be changed after they're created. So when a function receives that object reference we just talked about and uses a method like .append to add a value, it isn't creating some brand new list. Nope, it's modifying the existing list object directly in place. And because it's the exact same object, that modification is going to be visible everywhere that list is referenced.
Okay, let's see how this all comes together in a worked example. This is exactly the kind of scenario you're going to see on an assessment. First, we define a list, my_scores equals a list containing the number 10. Simple enough. Second, we pass my_scores into a function called add_scores, which takes a parameter called scores. Inside that function, we have a for loop that runs a .append method adding the number 5, and it runs exactly twice. So the big question here is, what is the final value of our original variable, my_scores, after the function finishes its job?
The absolute most crucial point here is tracking the variable through the loop step by step. At the start, right before the loop runs, our variable points to a list containing just the number 10. Then, in iteration 1, the code executes .append 5. And because it's an object reference, it modifies the list directly, right? So now it's 10, 5. Then iteration 2 runs, executing .append 5 again. The list grows one more time. Now that underlying list contains 10, 5, 5.
Now here is the really mind-blowing part of all this. Even though all that appending happened inside the function, using the parameter name scores, our original variable my_scores, which lives entirely outside the function, points to that fully mutated list. Its final value is exactly bracket 10, 5, 5 bracket. The function literally used the reference to reach outside its own local scope and permanently update the original object. Pretty wild, right?
All right, so you've seen the mechanics in action. Let's shift gears for a second and give you a transfer task to practice what we just learned. Think of this as your rehearsal for the actual assessment. I'm going to walk you through a short code snippet, and I want you to predict the final value of the variable. Just keep those concepts of object references and mutable lists fresh in your mind.
Okay, here is your challenge. We have a code snippet where we start with a variable x that equals a list containing 1 and 2. We pass x into a function. Inside that function, the parameter is called lst, and the function runs lst.append 3. So after the function is completely finished running, what's the final value of x? Is it option A, 1, 2, option B, just 3, or option C, 1, 2, 3? Take a quick second to trace the data, just like we tracked it step by step a minute ago.
Got your answer? Well, if you chose option C, you are absolutely right. The function did not make a copy of x. It received an object reference to the list. When it ran .append 3, it went straight to that original list in memory and just tacked the number 3 onto the very end of it. So when we check the value of x afterwards, it proudly displays all 3 numbers, 1, 2, and 3. Option A is a classic trap for people who think functions make copies, and option B is a trap for anyone who thinks append overwrites the whole list.
To wrap up this assessment rehearsal, I want to leave you with this exact rule, pulled directly from the Python documentation on control flow and functions. It states, and I quote, "If a mutable object is passed, the caller will see any changes the callee makes to it. The caller is just the code where you started, and the callee is the function you called. Because a list is mutable, any changes made by the function stick for good." So, as you head into your assessment, I'll leave you with this one provocative thought. We just proved this happens with lists. But knowing what you now know about mutability, what do you think would happen if you passed a Python dictionary into a function and updated a key? Keep that curiosity alive, and best of luck on your assessment.